So x plus x plus x is 3x. That means to get x by itself, what do we do? Divide by 3. So each x is worth 10. So we have 10. 2y plus 2y is 4y equals 18. So we have 10 plus 4y equals 18. Subtract 10. So whenever you solve for variables, you do the opposite of the order of operations. You do addition, subtract, get rid of addition subtractions first. Divide by 4. So each y is worth 2. So we got rid of these two. So we have 2y minus 2z equals 2. Each y is 2. Two times 2 is 4. Now what? Subtract 4. Two minus 4 is, plus 4 is bigger than 2. It's negative. Okay, now, I know you guys for years have been taught to divide by -2. No, because the bigger the equation, the more signs and symbols you have. If you divide by negative, that's just extra stuff you have to worry about. Treat your signs and your numbers separately. Here, we have to get rid of the negative first. So just change all the signs. Change this to be positive and change that to be positive. Just basically what you're doing is you're multiplying everybody by -1. Just so no matter what you have, anything, if it's a plus, change it to negative. If it's a negative, change it to a plus. Now divide by 2. You don't have to worry about writing it because that's besides just negatives, dividing by negatives is the next biggest problem students will have errors in. Because you'll if you forget to put a negative, you may put a negative here, forget to do it on this side. So treat the negatives, the signs and the numbers separately. So now we know z is 1. We have x equals 10, y equals 2, and z equals 1. So our last equation is z plus x, which is 1 plus 10 equals 11. Pretty straightforward. Once you look at that way, the most common, guess what number I got the most of? Because when you look at the picture, you think Coke's come in twos. So the Coke is worth 2 points. This will lead into our topic today is chapter 1, section 1, functions. What is a function? Yes. And it passes what other test? No. That would be, yeah, that's a function. That means it has an inverse, right? A function, well, we're used to seeing equations like this. If we were to graph this, the x-axis is here, the y-axis is there. The thing with this is y is our dependent variable. Why is it called a dependent variable? Yes. You cannot tell me what y is until you tell me what X is. X is independent. X can be anything as long as it doesn't violate the rules of math. Once you define an X, plug it in there, then you get a value for Y. So, but what this doesn't tell us, the variable Y doesn't tell us what variables are in our equation. Functions are written this way. This is the function name, and this is the variable in the function. So that's the independent variable. It's the same thing as Y. It just looks different. It looks more impressive, actually. If you want to impress people at parties, put a function down. So Y and f of x are the same thing. That's how this is read. F of x. The function f of variable x. We just call it f of x. Another benefit of using functions as opposed to using the y's or z's or m's, whatever's the letters, is I don't have to. I define my variable when I write the equation. Oh, I'm sorry. Do you need more? I'm sorry. I saw you writing. I'm sorry. For example, if I said as opposed to this, this way requires a lot of extra writing. I have the equation. I got to define the variable. In a function, I define the variable right off the bat. Anything that's inside the parentheses goes in place of x. So 3 times 3 is 9, plus 4 is 13. So f of 3 is 13. I can define any type of equations I want to, any type of functions. Just that once I define the function, it remains that equation until I redefine it. So here, what if I ask you, what if I gave you these equations to do? So work all three of these out. So in this first one, this says I go to the function f. I use this equation. Anywhere I see an x, I put a -2. So in other words, what you really have here is this. Whatever's inside the parentheses is your input. After you plug it in the equation, let's say 3 input plus 4, you get an output. So whatever's inside there goes inside the x inside the equation. So what this one says is -2 squared plus 3, 4 plus 3 equals 7. This one says go to h. Anywhere I see an x, I put a 1. 1 plus 1 is 2. 3 times 1 is 3. So the answer is 2/3. Now this one, I have a sum of two functions. First, I go to the g, which is 3 times 1 over 4, because that's my x value. And then for the f, I have 3 squared plus 3. It's always safe, whenever you have a function after another function, put the second one, anything after a sign, put it in parentheses, in case there's a sign change. 3 times 1 is 3 over 4. 3 squared is 9. 9 plus 3 is 12. Then what? Butterfly, yes. I like the butterfly.
Why don't you do that? Instead, you leave it, not put it in, improper fraction, keep it as a mix. Put it in the mix.
We have to first find out what the value is going to be. Well, I mean, yeah, we could get 12 and 3/4 because it's an integer, but as practice, so get everybody to learn how to combine two fractions. You're right. Since this is an integer, it's just 12 plus 3/4 is 12 and 3/4. So using the butterfly method, 3 times 1 is 3. 4 times 12 is 48. Plus sign between there. 48 plus 3 is 51. 4 times 1 is 4. How many times does 4 go into 51? 4 goes into 5 once. 4 goes into 11 2 times. Since 3 is smaller than 4, it's 12 3/4. So that's the beauty of functions. I don't have to keep on rewriting the equation. I just put in the reference to it. And I define the variable inside the function call. What? Let's see. Domain and range. What's the difference? Very good. So domain are all possible x values that you can use, and the corresponding y values is the range. What's the domain and the range of this function? To figure out the domain, you have to ask yourself 3 questions. Can X be negative? Can I put a negative in there? Yeah, it's not going to change anything. Yes. 2. Can X be 0? Can I put a 0 in there? Yeah, it's not going to violate any rules of math. Can X be positive? Yes. So if all 3 of those are yeses, then my domain is from negative infinity to positive infinity. Because they can be positive, they could be negative, and they could be 0. So on a number line, it's everything from negative to positive infinity. It's everything. And if you don't want to write this all the time, what does that look like? It looks like the real estate symbol. No, it's for sale. It means all real numbers. In other words, there is no limitation of what you can put inside there. So now, since we can put positive, negatives, and zeros in there, what about my output, my y values, my range? Can my range be negative? Yeah, it's not going to stop it from being negative. Can it be 0? Yeah, because if I had positive 3/2 as x, it'd get 0. And can it be positive? Yes. So again, this is from negative infinity to positive infinity. Typically, if you drew this graph, what would it look like? A straight line. It's a line. We call these linear equations. Linear equations define a line, whether it's horizontal, whether it's vertical, whether it has either positive or negative slope to it. How do we know it's a linear equation? By looking at it. X has no special operation to it. X is not on the bottom. X does not have a square root, a square, an absolute value. X is just X. That means it's a linear equation. Glad you said that, because now what this means is, what about this function? Why is it called a quadratic? And what does that mean? Is a parabola. That's the graph. It's called quadratic because the largest exponent is a 2. What is that one going to be called? Very good. Called a cubic equation. And it just does that. It defines a cube. But the differences between the two are pretty immense. Again, this one's a cubic because the largest exponent is a 3. So in a cubic equation, that's an example of a cubic equation. I want to get you to a point where just by looking at the equation, you can tell me what the graph's going to look like. We'll talk about it in a little bit. And we're going to talk about the graphs of these in a second. What's that called? It's a radical equation. In this case, it's a square root. What's that one called? It's also a radical. Radical simply means this little symbol's around it. This is a cube root. It gets its name. Okay, and I'll give another one. What's that one called? This first one's called a square root. Next one's a cube root. What's this one called? Seventh root. As you can guess, mathematicians go to no expense naming their functions. They're not that imaginative. The number cubic means 3. That, because it relates to that number. This is called a root. This is the 7th root, 3rd root, or cubic. There's an invisible 2 here. It's square. Now, I'll show you the differences of these in a second. How about this is an irrational equation, but it's got a different name. Because rational equations can also look like this. These are both rational because rational ratio is a fraction. This is squared, and this is linear. Doesn't mean it's going to be a line. It just means there's no x on it. There's no power. Again, there are other names. You'll hear a couple of different types, but basically we just go by the general term rational. It means fraction. X is on the bottom. How about this one? Absolute value. Exactly. It's an absolute value equation. No, it's a number. What is that one called? Huh? What kind of equation is this? No, actually, it's not a point. This is a graph of a line.
Oh my God.
Can 5 ever change? So it remains what? If it doesn't change, it is constant. And we're going to talk about the graphs of these and domains and ranges and restrictions, all that in its due time. Let's see. Some of y'all may never have seen this one before. It looks like it, but it's not. No, we'll call it that though. This is called the greatest integer function. Basically, all this function tells us is no matter what your number is, if it has a decimal, drop the decimal. If it's 1.05, it's just 1. So this only gives you an integer answer. If you had 0.59, it's 0. So that's what this one says. Nope. It's just truncating. Just anything after the number, decimal, delete it. You're right. That's a good question. Is if you round it, you have to worry about to what decimal place do you round it. And the graph of this one is called the stair step method because it looks just like stairs. Let's see how many we have here. So there are supposed to be 14 or 16 functions. Linear, constant, quadratic, cubic, square root, cube root, rational, absolute value. All right. So let's look at these now. Give me the domain and range of this function. Before we go on to figure out domain and ranges, we have to understand what this function is. What is that function? It's a radical. It's a square root. What does square root mean? Remember, there's an invisible 2 there. So let's look at this. What is the square root of 4? What is the square root of 36? What is the square root of 16? Now my question is why? Why is this one 2? Why is this one 4? Why is this one 6? Right. So if we factor out the number inside the radical, what is 4 made up of? 2 times 2. Remember, this is a square root, right? There's an invisible 2 here. What this root tells us the number of times a number needs to be multiplied to itself. So what this says, since that's a square root, as soon as we see 2 of a kind, it comes out. And since there's nothing left inside there, the radical disappears. Same thing with 36. Let's break down 36. What do we get? 6 times 6. Since we have 2 of a kind, there we have it. Same thing with 16. With 16, you could have gone 2 times 8, right? 8 is made up of what? 2 times 4. 4 is made up of 2 times 2. So 16 is made up of 2 times 2 times 2 times 2. We need how many of a kind? Here's a pair, so it comes out. Here's another pair, it comes out. 2 times 2 is 4. That's the whole structure of a radical. The same thing would apply for here. Let's say we had cube root of 16. How would you do that? Yes. Yes. Because you know that 16 is 8 times 2. You could say cube root of 8 times the cube root of 2. Why would you do that? Right, because 8 is made up of 2 times 4, and that's 2 times 2. 1, 2, 3. So the cube root of 8 is 2 with that left over. So there's your answer. Right? Nope. We'll do a whole bunch of these types of questions. Or instead of doing that, we could have just started over here. 16 is made up of 2 times 8. That's a prime number. 2 times 4. That's a prime number. So we have the cube root of 2 times 2 times 2. We have 4 2's. We need how many of a kind? Once we see 3 of a kind, it comes out in front. Anything left remains in there. That is really what's happening. Now, so far so good, which helps us now define the domains and ranges of our functions. The domain. Can x be positive? Yeah, because that's what we've been taking along. Can x be 0? The square root of 0 is 0. Can x be negative? Why not? That's what it becomes, but no, that doesn't mean why not? Why can it not be negative inside there? And exactly. Two identical numbers cannot multiply to give you a -4. If you put -2 and -2 in there, that equals what? +4. You can't have one of them because they're no longer identical. So that's the reason we cannot have negatives inside our square roots. So the domain is x can only be greater than or equal to 0. But how about cube root of -8? Can we have negative 2 times 2 times 2 is 8? Can it be negative? Yes. So the answer here is -2. So the domain of this equation is all real numbers, positives, negatives, and zeros. Right, yeah. So in other words, we can extrapolate. We can now come up with a general idea about radicals. If the root is even, the domain is greater than or equal to 0. Because if you have an even root, that means they have to pair off. And you can never have a negative answer when you pair off two numbers. If the root is odd, domain is all real numbers. It could be positive, negative, and 0. This is the way we prove things in mathematics. We take an idea, we put some numbers in there, see what happens. And then we come up, we extrapolate an answer from there. So what would the radicals look like? What would the graph of radicals look like? Let's look at it. So let's say we had f of x equals the square root of x, the basic symbol of that. This is our x, this is our y. One, 2, 3, 4, 5, 6, 7, 8, 9. Can you put 0 in there? Square root of 0 is 0. We create a table. We put 0 in there, square root of 0 is 0. So we have that point. When x is 1, square root of 1 is 1. When x is 4, the square root of 4 is what? 2. When x is 9, square root of 9 is 2. So we notice that it takes a long distance. Because what's the next one after this? Then after that is 25. And it only goes up 1 point. So the graph is a curve like this, which tells us that it grows further out to the right than it does up. So that's the graph of square root of x. It becomes much easier to tell me the domain and range. If you have a picture, you can just look at it and tell me the domain and range. What's the domain of this function? Yeah, x can be greater than or equal to 0. Or it could be written as that. The bracket simply means that I can include 0. Parentheses means I can go all the way infinitely close to it. I can't use it. So how about the range? Remember, the domain are the x values of this graph. I can start at 0. I go to infinity. What's my range? 0 to infinity. Very good. So that's the square root of x. So actually, we can go a little further than that. We said it earlier that if the root is even, it's x equals 0 or greater than 0. So this is for any even root. The 4th root, the 8th root, the 100th root. It'll always have the same graph. It just won't be as high. So if it's an even root, it'll have the same basic graph. How about the cube root function? Yeah, our domain and range, because we can put negatives in there, we can put 0 and positive. So let's look at the graph. So in our function, when x is 0, what's y? 0. When x is 1, 1. When x is negative 1, now our domain says we can use positives and negatives. When x is negative 1, negative 1. When x is 8, cube root of 8 is 2. And of negative 8. So the graph of this one looks something like this. A stretch out S. And it goes on from negative infinity to positive infinity. Up and down and around. So far so good. Are these functions? How can we tell they're functions? What is the vertical line test?
If more than 2 points touch the vertical line.
Very good. If a vertical line crosses more than once. So anywhere along the graph, if a vertical line crosses it more than once, it's not a function. We looked at quite square roots and cube roots. But again, this is for any odd root. The graph is the same for any odd root. The fifth root, the seventh root, the ninth root, it all has the same basic shape. Let's look at the opposites of those, the inverses of those. We know this is called the quadratic equation. What's the domain and the range? Let's look at the graph of this one. Can x be 0? We get 0, so it goes through the origin. What if x is 1? What's y? When x is 2? When x is negative 1? There's negative 1 times negative 1. And when x is negative 2? Yeah, it's a parabola. This is a parabolic function. Parabolic functions have curves opening up or down. They also have what are called vertices. That's the plural of it. This is actually called a vertex. It's singular. What is a vertex? It's the extreme point on a curve. If it's the lowest point, it's called a minima. If it's the highest point, it's called a maxima. How can we tell which one we're going to have before we even graph it? What's that? Right. It all depends on the coefficient of x. The coefficient of x. If a is positive, then our graph opens up. We'll have a minima. If a is negative, it opens down and we'll have a maxima. Again, so by looking at these, we know that what it's basically going to look like. And I'll get to what these really mean in a little bit. How about the cubic function? Okay, so for this one, I'm sorry, we didn't say a domain. What's the domain of this one? All real numbers. Because they could be negative, they could be positive, and 0. What's the range? Yeah, y is strictly greater than 0, or 0 to infinity. It has to be one side of the y-axis. Let's look at this one. If X is 0, what do we got? 0. If X is 1, what do we got? Yeah, 1 cubed is 1. If X is 2, what do we get? What's 2 cubed? 8. So 2 and 8. If it's negative 1, negative 1. If it's negative 2, yeah, so the graph here looks something like this. These are, I just gave you the first 4 inverse functions. The inverse of x squared is square root. The inverse of x cubed is cube root of x. So the domain, all real numbers. The range, all real numbers. So far, so good. Absolute value of x. And you have 0. Absolute value of 0 is 0. Absolute value of 1. Absolute value of 2. Negative 1. Negative 2. So the absolute value is simply linear equations. One has a negative slope, one has a positive slope. But the answer can never be negative. So the domain here is all real numbers. And the range, 0 to infinity. Right. It's north of the x-axis. One over x. Here we have a reciprocal function. Right? X is 0. What do we get?
1.
Yes, sir. Undefined, right. You cannot divide. That was a trick question. You cannot divide by 0. So what we have here, 0 is what we call a vertical asymptote. An asymptote is an invisible line that you cannot cross. Well, yeah, in the vertical line. You cannot cross it. Where do vertical asymptotes come from? Any x value that makes the function undefined. Basically, what that means is any x that makes the bottom equal to 0. That's an asymptote. So any when you factor it out and everything, you solve the bottom, any x value that makes the bottom 0 is an asymptote. So we can't use that. How about 1? When x is 1, what do we got? 1. When x is 2, 1/2. When x is 10, so we see that our graph is from this point is going down forever and closer, 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 closer. It can never reach 0 because 0 is our horizontal asymptote. We'll talk about that later. But since we cannot use 0, how about between 0 and 1? What happens there? What if x was 1/2? 1/1/2 is 2. Flip the bottom number. So 1/10, 1/110 is 10. So this graph looks like this. What about the negative side? Can they be negative? Mm-hmm. If I put negatives in here, if I put -1, I got -1. Put -2, -1/2. So what I have here is this half of the graph. So that's what it looks like. So the domain here, -infinity to 0, union with 0 to positive infinity. I can go from -infinity all the way to 0. I can't use 0. Start from there, go to infinity. Same thing with the range. I go -infinity to 0, and then from 0 up. But I can't never reach the endpoints. One more. Yes, sir.
Whenever you're writing out asymptote, it's always open parentheses, right?
Yes. Yes. Because the bracket means you can, if you put 0 in there, then it's an undefined function. So that's why whenever you have asymptotes, it's always going to be a parenthesis at that, parenthesis at that. And also with the infinities and negative infinities, those are always parentheses because you can never get to them. Let's look at the squared. 1/x². Again, whenever you have x on the bottom, do we have an asymptote here? Yeah. You cannot have 0 for x. So you can't have 0. How about 1? It's 1. 1/1² is 1. 2. 1/4. 3. 9. So it gets smaller really quick. And then between 0 and 1, we have 1/2 becomes 1/1/2 squared, becomes 2 squared, makes it 4. At 1/2, it's 4. So it grows much faster because it's squared. How about the negative side? If I put -1 in there, what happens? It's going to be a positive. It'll be +1. So anyway, anytime I put a negative number, it becomes positive. So it's simply going to be a mirror of the positive side. It's going to, what I call the Atari symbol. It looks like the Atari symbol. Because whenever your function is squared, you can never have a negative answer. The domain, -infinity to 0, 0 to +infinity, and the range from 0 to +infinity. So far, so good? Yeah, because once you understand these, then we're going to look at transformations, shifting them and stretching them and shrinking them. What time we got here? Oh yeah, 5 minutes left, don't we? We did square roots, cube roots, reciprocals. Got that one.
When you draw a straight line.
Nope, not up and down.
Can I show you?
You did this, didn't you? Because no matter what X you put in there, what's Y going to be? So it's a horizontal line. A constant function is a horizontal line. Linear function. Where's that going? It's a positive slope because the coefficient's positive. Because yeah, you're right. It would look like this. If A is positive or A is negative. If A is positive, it looks like this. If A is negative, it looks like this. But it has to go through the origin because it doesn't have any vertical shifting or horizontal shifting. And the last one, I believe, when X is 0, Y is 0. When X is 0.5, it's 0. Remember, this is the greatest integer. Drop the decimals. So it's also 0. When it gets to 1, what's the answer? 1. So here it's an open circle and it jumps up to 1. Open circle means we can get infinitely close to one, but as soon as we get to one, it equals one. And it stays that way all the way it gets to two, and then it jumps up to two. And then all the way up to three, and it jumps to three. You see why they call it the stair step function? We call this a jump discontinuity. They're continuous. The function is continuous. You can say, because I can have each value from negative infinity to positive infinity, each value exists, but they're not connected. There's a jump between here and here and here and here. But my entire domain's accounted for. So far, so good. This shouldn't take long. Okay, clear your desks. Clear your desks. Okay, I'll see you on Monday. You don't have to clear your desk anyway. Y'all have a great weekend. Be safe. You want me to give you a quiz?
No.
You haven't been here in a while.
Yes, I've just been busy with work, so then,
Yeah, and so if again, if work gets too much, you can always participate online.
Right.
On Zoom.
yeah, I just wanted to come in and see how it was in class too. I think
It's-
I'll either
so-
do either or.
Well, see, yeah, sometimes like last time we had a competition, a little an exit ticket where if you got it right, you got a candy.
Right.
You can't do that much.
Did you the remind stuff? You approved it?
Yeah, all those should be, check yours, because it should be approved already. Because I checked it and there was nothing left on there. But yeah, so and I don't take a roll call and it's always the same. And then like today, as soon as this video is processed, I'll take the video, scan my notes and send them all to you.
And then on my matter, everything's good, right? Or they
No,
still-
because they gave me a trig book.
Yeah.
The reason they gave me a trig book was I forgot to tell them what class I'm teaching.
Okay.
And so they're fixing it right now.
Okay.
So as soon as that gets up, I will get the homework assignments for the first chapter and send it off to you so you get started.
Okay.
So yeah, it was my complete fumble there. I gave them a book request,
Right.
never told them a class, so they just made up a book for me. So
Sounds good.
yeah, I'll send y'all a note when it's up and running.
Okay.
All right.
All right.
Have a great
Thank you.
weekend.
Thank you.
Yes.
Oh, Professor
Yes, sir.
My name's Miguel Ramos.
Yeah, yes.
I apologize. for missing your class.
No. It's the door's always open. So if you ever need to come in and go, and you didn't disturb anybody, you sat over there.
I went to the room W196.
Well, we used to have class, yeah, and then, but because the class was too big for that room, and nobody wanted to walk that far. So yeah, I'm trying to see if we can even put it on the first floor so we don't have to climb any stairs.
I mean, there's no issue going on here. I just have followed the syllabus, and they said one.
See, and that's probably, yeah, that's why I had to put the syllabus because that's what the school expects. And they give us they give us a template. We just have to fill in our own basic information. So the rest of the stuff is what the school gives us. But like for me is our deadlines, even though in the calendar, I said, these are your dates. I only have one date for due dates.
It's
The end of the semester, 11:59 PM, May 9th. You can do it now, you could do it then. As soon as it hits midnight, it shuts off and makes zeros all the grades you haven't done. And that's what I grade.
that's how it was when I took it through.
Yeah,
College. I was-
yeah. Because because life happens. I mean, a lot of people have work, they have family, if they get sick, especially this time. My boss has been sick for 2 weeks because of the flu and what's going on. And it's not fair to penalize you guys if you guys are sick or something comes up, because family's important, work's important. So schedule yourself so you know that as long as I'm finished by end of the semester, I'm good to go. And again, if do you have any classes before this?
Oh, no, this is my own.
If it's really fast, then you can always participate from home. Yeah, and it's that way you'll see what we see, and if you have any questions, you can just either on the speaker, nobody see you, just you have your voice up from the heavens, or you can send a question and I can answer that way. So yeah, so if this is your only class, especially in the stupid parking lot they have now.
Oh, but how I shut off everything?
Yeah,
Yeah, and it's only like small spaces, yeah.
it's ridiculous. I mean, trying to find a spot to park is impossible.
You had to come like at least 15 minutes early just to find it.
Just to wait to find something. Exactly. So, I mean, and I won't take off any. So, I mean, you'll have the same participation. So only thing you won't get is if we have candy, like we have a exit
Oh,
ticket.
yeah, last class.
Yeah, like that class S. So that's the only thing you won't get. But even if we have it for points for a test, you can participate when we do Kahoots from home. You sound good?
Yeah, and then my other question is, the website's still down, correct?
Well, no, the website's finally up and running. It's just that they haven't given me the right material
Our material.
because I forgot to give them the name of the course, the number. I gave the name, but they needed 2412.
2412.
They needed that, and I didn't give it to them.
They
So
gave you trig instead.
they gave me trig because this course is both algebra and trig. And
Like a mix of it.
yeah, so they thought, well, we give them trig.
Trig.
So it was 100% my fault. And when I saw it, I felt like an idiot. So, but they're going to fix it. They said they're going to fix it today because we're in the second week. They're going to do it as fast as they can.
I've been waiting those assignments.
No, yeah, it's just, and like in algebra, my assignments won't be large. You'll have maybe 10, at most 15 questions. But usually if the material is difficult, 8 or 9, 7, 8 or 9. But if it's mediocre, 10 questions. And if it's easy, no more than 15. So yeah, because I don't want you to spend your entire day and night doing the same type of problems over and over and over. And same in algebra, you have unlimited tries to get a best grade. Same for the test. So you have 3 tries, but if you need more, just ask me and I'll give you those. And everything's on your own free time.
Because everything's due at the end of the.
And yeah, if you want to take the test, I mean, if you want to finish the semester now, you're more than welcome to finish the semester and get it just kicked out.
Or like, you mean like finish on your own.